by doing a lot of the historical analysis, we can see that, okay, maybe for people that are always trading on Uniswap and
like what even an execution layer is.
spinning up a lot of Altius or sidechains, it doesn't really solve the core problem, which is bring scalability and performance improvement to a very specific.
Do we have to keep upgrading hardware as new things come along? How does that work? Welcome to the Deco podcast, where we bring you stories from founders and investors in Web3. Before we get started, this is not a financial or legal advice. It's just a conversation about things we find interesting in Web3. Views expressed are our own personal opinions. Deco members or guests appearing on the show may have positions on assets they talk about. Hi, today we have with us Annabelle Huang. She is the co-founder and CEO at Altius Labs. And today we are going to talk everything about Altius and try to understand what they are doing. Hello, Annabelle. Welcome.
Hi, thanks for having me.
Okay, just to get things started. From whatever I have read about Altius, I understand that it is an execution layer, right? So can we just get started there? Like what even an execution layer is and how Altius is working with execution layer and how it works with, different L2s or different EVM chains.
Of course. So just going back to the basics, we can think of blockchain infrastructure having 4 different layers when we talk about what a blockchain is. So from the very bottom, we have settlement, and then you have consensus, which is where you get the decentralized network to agree on the current state of the blockchain, to agree on finality, the current state. And typically, or from a more kind of legacy infrastructure, the execution layer is typically coupled inside the consensus. So typically the smart contract will be executed and the state of the blockchain will be updated, and then it will be confirmed. And that's where we get to finality. There's also a separate data availability layer, which is what Celestia and a few other teams have done in decoupling that and make it into a modular layer. And I think that's where a lot of people have heard of modularity at first, but modularity can be applied to any layer in an infra stack. And what Altius has done is to further decouple execution from consensus and want to bring specific optimization directly at the execution layer. This way, we can work with either existing chains or newer chains coming to market without a complete overhaul of redesign of the current consensus, especially if you're dealing with a very highly decentralized network validators. And it is really a trend as well as modularity is further embraced. There are teams that bring specialized expertise or skills that can be applied to a very specific set of problems. So instead of, if you remember the 2017, 2018 era after Ethereum, there are lots of new consensus designs that supposedly will become the Ethereum killer. And I think that paradigm has shifted where people focus on bringing specific optimization to specific layers of the inference stack to bring overall optimization in terms of performance or cost or latency. So what we want to do is to build on that trend. And our team of engineers mostly come from Web2, Silicon Valley background, and high frequency trading infrastructure background. So we wanted to apply what we have learned from decades in Web2 that with proven scale and try to apply that in Web3.
All right, that's helpful. Let's dig into it a little bit more. Okay, so let us say that I want to submit my transaction to any L2 that exists there, and presumably they are working with Altius. So can you walk us through the moment I submit my transaction to the RPC that I'm connected to? What is happening after all of that until the final settlement of that transaction?
Of course. And I want just to caveat that talking about modularity, but LTS framework and the LTS stack is designed to work with not just rollups or not just EVM rollups. We're actually set up to build something that's VM agnostic. So wanting to target a broader ecosystem, EVM, it could be, even the newer generation virtual machines as well. And in terms of the chains that we could work with, it is rollups, of course, and also L1s, depending on their current architecture. So to your question specifically about L2s, it's interesting because you can think of L2s itself as execution layer already, right? They are roll up from Ethereum mainnet and using Ethereum as a settlement layer. But what they're doing is by spinning up an L2 and spinning up new generalized block spaces to accommodate for extra demand, kind of move the traffic away from mainnet. But that creates additional fragmentation, a liquidity fragmentation, UI UX fragmentation issue. And if you look at it, if we're being honest, there are a lot of these block spaces are not even being utilized. But the ones that are, maybe certain perpdex chains or certain highly utilized or demanded chains and apps, it's still running into congestion. So what Altius is trying to target here is to bring further scalability into the purpose-built or demanded block space. And back to your original question, how it works, you can think of it as currently our design only really touches the execution part. What I mean is there is the normal block building or sequencing approach. So the transactions are ordered within a block, and we only speed up or bring more improvement during the execution, which means executing smart contracts and updating the state from n to n+1. And then it goes to consensus to be for that transaction, for that batch of transactions to be confirmed. And we get to actually a finality. So we don't really directly tap into sequencing or block building or consensus, but it's deeply interconnected. And I believe that there might be other teams that are working on different parts of the Lego, maybe bring more interesting designs around block building, sequencing, or around consensus, and we can be compatible with any of those.
Okay. So is it like you bring in kind of elasticity to capability of execution?
You can think of it as just making the execution process much faster and more efficient.
Right.
You can execute or process more gas per block.
Right.
And you can get the block execution time can be significantly improved. So your overall latency could be improved. And other optimizations around data access or database read and write can also lead to further sort of hardware optimization as well.
Right. I'm curious about like what are the numbers that we are talking here? Like, first of all, how did you narrow down on execution as the problem? And in tests, what are the numbers? What is the improvement that you are seeing?
So it's interesting. We start thinking about building the next generation high performance infrastructure in a much broader sense. And there are consensus researcher experts on the team, obviously, team of engineers coming from high frequency trading background that are experts in distributed systems, distributed caching, and high performance computing. So we realized that if people either building L1s or L2s are happy with the current consensus design, we're seeing a lot less sort of newer change with newer consensus. They're just minor tweaks or optimizations done at each layer. There are people bring cheaper and higher throughput data availability. And we thought it could be interesting to leverage our expertise to bring optimization at an execution layer. And what we're doing is by introducing multi-threading, so parallel execution to VMs, to EVM. Obviously, it's currently still a sequential execution. There are some other VMs like Solana or MoveVM that has introduced different levels of parallel execution already, but there are additional optimizations we can bring in. And a very big part of the bottleneck, actually, if you look at block execution time, is at the database IO, the database read and write state access. And that's also a very specific problem, very niche problem, where our team has worked on in a similar and in a Web 2 setup for decades. So they wanted to also apply what they've done, what they've built before to Web 3, to blockchain specifically. So bring optimizations there as well. And that evolved into the overall LTS framework. And that could be, again, applied to EVM rollups, other EVM L1s, or in a much broader sense, any blockchains, really.
Okay, can we talk a little bit about benchmarks of like
What the benchmarks are like within on-chain, and then how it can be helped to, achieve the levels of, let's say, Visa, which are like the pretty real world applications, and they have withstood the, pressures and congestions of the like real world load in terms of number of transactions?
Yes, of course. I mean, there's still different assumptions here, right? Depending on what the consensus designs are, if we're talking about latency and finality, but we're doing our best to at least shorten the execution time, and which contributes to lower finality time or latency. In terms of throughput, our goal is to improve transaction per second, but that's kind of an outdated metric. What we're really looking at is gas per second. So how much can you process per second, especially as we looking at not just native transfers, like you can think about it, just ERC20 transfers versus complex swaps, Uniswaps or other sort of DEX swaps. So I think in terms of gas per second as a more accurate measure of how much you can process per second. And if you're looking at, obviously, even if you're a mainnet side, most of the L2s are probably below 100 million gas per second range. Everyone is targeting gigagas per second, and different chains are working on different optimizations. Some are even going down the route of building your customized database, which is, a completely different and very big undertaking. But what we can offer is instant performance improvement toward Gigagas. Our current benchmark on the Altius REVM, the Rust EVM, with parallel execution and more optimized in-memory state access can puts us to above 1 gigabyte of gas per second, or 1 gigagas already, with further optimizations to come. In terms of TPS, that number would vary, depends on what
Right. What kind of
benchmark, what
transactions?
data set
Yeah.
you're running. It could range from, maybe tens of thousands to hundreds or even millions of transactions per second. But I would say average is probably around tens of thousands to hundreds of thousands if you're benchmarking against real Ethereum data, historical data. That's the first set of improvements we're working on. Again, we also want to hear more feedback in terms of what the builders are looking for, what specific applications they want to support, and that could mean different optimization as well.
Right. And obviously, this is possible because of instruction level parallelization. So I will tell you what I understand, and you can correct me if I'm wrong. All right. So, whatever parallelization of transactions that exist today, it is at a transaction level, which means that two transactions that are not conflicting can be executed at the same time. So, let's say if I want to transfer it to Joel, and if you want to execute, let's say, a swap, those two transactions are not conflicting each other. I mean, they are not independent on each other's states, and they will be executed parallelly at the moment. But transactions, like if I wanted to execute two transactions wherein my balance itself is being looked at by those transactions, then it's difficult for those transactions to get executed at the same time. So instead of executing transactions parallelly, we are executing instructions parallel. So transaction essentially is a superset of instructions. Like one transaction will have multiple instructions within it, right? So one of the instructions can be check balance. Another can be, if you're interacting with a pool, you want to check the pool's balance. And if you want to transfer to somewhere and their state, like their balance is increasing, it could be that increase their balance and reduce my balance, right? So when the instructions are not conflicting, they can be executed at the same time. So instead of being at the surface level, you are going more granular and executing instructions instead of transactions parallelly. Is that a fair, explanation?
That's exactly correct. So the way we approach the optimizations to bring performance improvement to the execution layer are twofold. One is the state access, which is more touching around database, around storage, and how to read and write. And that's actually probably the majority of the bottleneck currently. And then the second part, which is also an important part, is introducing multi-threading and parallel execution. And the way that we do that is introducing a more granular parallel execution. So exactly like you said, transactions are made of opcodes or instructions. So the traditional parallel execution or the traditional optimistic concurrency control is you'll execute everything in parallel, and then when you run into conflict, you'll go back to re-execute those transactions that are conflicted with each other. And oftentimes, entire transactions may be tens, hundreds of opcodes. It could be just one opcode inside that's directly conflicted with another transaction. But in this case, you would have to re-execute the 100 opcodes anyway, and each line of opcodes costs gas. So what we want to do is, by looking deeper, having more analysis within the transactions and look into exactly which lines of the opcodes are conflicting and only re-executing those. So improving the overall transaction speed by reducing the amount that needs to be re-executed when it's conflicted. And there's another interesting part where by doing a lot of the historical analysis, we can see that, okay, maybe for people that are always trading on Uniswap and doing this or minting NFTs or common conflicts that maybe could be improved if the smart contracts are rewritten in a way that is more parallel or multi-thread friendly. And in that case, we can even reward the developers or build some sort of developer tooling, some sort of compiler that tells the developers, hey, if you rewrite or you restructure your code in a certain way, you could save gas, or maybe you can give incentives for them to do so. So overall, we wanted to really getting to the nitty-gritty of parallel execution and introducing a lot more granularity and a lot more other aspects of the optimization on top.
And I understand that ballpark number is 75% improvement in gas consumption. Is that right?
Well, again, that number could be varied, depends on what data set you're running. But yes, what that means by looking at the overall transactions, I think we're benchmarking against real Ethereum data and looking at the ones that would be re-executed and looking at the amount that we are re-executing. That's the improvement that we see.
So, on the one hand, you are being efficient about how you consume gas. And on the other hand, you are also increasing how much gas you can spend per second.
Well, that is the challenge, right? How do you reduce block time, but still make sure that you're processing more per block in a sense? So, yeah, that's what we try to do just to bring efficiency at all the levels.
All right. So, one thing as I understand Altius is most of the times when these new execution environments launch, it is bound to happen that, they will take some share of users or liquidity from the existing L2s and whatnot, right? But with Altius, it is different, right? You are essentially working with everyone to increase their capacity. And one can look at it from a point of view that it is a positive sub game for all the execution environments. So, yeah, can you expand a little bit on that?
Of course, and thank you for bringing it up because it's really our first principle thinking, or it's consistent throughout our design ethos as well. We set up to build a modular solution to really bring high performance as a baseline to the industry, as opposed to creating our own chain and telling developers if you want the Web 2 level performance, you have to come to us. I believe in a multi chain future. There should be application specific chains that are spinning up purpose built opinionated block spaces for a specific use case. And we want to help them get the most up to speed performance and infrastructure they can. To be honest, from a technical perspective and maybe even go to market, it would have been much easier if we launch our own L1 or L2. But I've been building this for a while, started in 2018, building one of the first generation DEXs on Ethereum on mainnet because there weren't any alternatives back then. And really seen through how much the space has evolved. And I still believe there are Ethereum and maybe Solanas of the world that will live on as the general L1, the general settlement layer. But as we see the improvements over the last few cycles, we're seeing a lot more Web2 institutions, enterprises launching their own app chains. Of course, the Web3 super apps launching their own app chains as well. So we really want to build for that future. We do what we do best, which is bring high performance to anyone that needs it, and so that they can focus on what they do best, which is building the application, building the right UI UX, onboarding users to build upon the ecosystem. I don't want to necessarily build another competitive chain, but like you said, positive sum to really bring what we can do to the hands of as many builders as we can. And I think that also goes back to maybe, last 6 years while building Amber, we really positioned ourselves as a service provider as well, a financial service provider, providing liquidity to projects, to anyone who wants to trade, to institutions, to VCs in the space, and working with many different foundations, the layer ones, the layer twos, different types of token projects. I really do enjoy that aspect of providing value, providing our specialty, what we do best to really empower an overall ecosystem and really want to find a sustainable way of doing that in the long term as well.
Okay. And when you say that, okay, before that, let me get back to your days as building a text, right? So I really want to understand what were the pain points back then and how Altius is trying to answer those pain points.
Yeah, well, as a throwback for sure. So when we were building AirSwap, and to be honest, I think it was a product that just a little bit ahead of its time. It's almost like a RFQ style DEX. You can think of it as the Uniswap X. The challenge was that the on-chain infrastructure was so nascent. It was so difficult to even get a wallet to onboard any users. And then it's really difficult for market makers to market make on chain. There's lack of API, lack of security, there's lack of liquidity as well. And obviously, liquidity begets liquidity. So until Uniswap came along, that solved the liquidity bootstrap problem where anyone can be their own market maker. That was really the initial set of challenge that drove me to build a market maker that will not just focus on centralized exchange trading, but also on-chain venue as well. But back then, if you remember MetaMask from 2017, 2018, right, I would have to say it's a very different experience. And so that's kind of like the initial onboarding, the transaction speed and the gas fee. Obviously, ETH was much cheaper then. So in dollar terms, maybe that it wasn't too crazy. But in terms of the amount of Ethereum that you spend, or even if people remember during 2020 DeFi summer, when everyone was trying to do one of the food coin or yield farming, the amount you pay, or during NFT minting, the amount of gas fee you pay. And I think that drove largely why Ethereum moved to a L2-centric roadmap. But as we found out, right, maybe by spinning up a lot of L2s or sidechains, it doesn't really solve the core problem, which is bring scalability and performance improvement to a very specific demand or dedicated or demanded block space. So that also drove further to parts of inspiration for building Altius.
One of the things that I spotted and I liked was there aren't too many rigidities around Altius, right? I mean, the most important perhaps is the being VM agnostic, right? So it doesn't matter what kind of execution environment you are, like you can, leverage it and help it scale. So yeah, like can you tell us as to how one builds that? Right? I mean, what is it that makes you VM agnostic? And obviously, what are the benefits of it? How can different developers who are working in different execution environments can, use it? And what kind of an effort is that for developers?
Of course. So it's also, we focused on the EVM builds early on with doing our research. And one day we just had this epiphany realizing that all the framework and implementation that we've designed is actually not dependent on just the EVM semantic. It's not magically VM agnostic from day one. There will be some uplift to say, okay, we build the EVM compatible implementation to move to, say, SVM, then we need to look at the SVM opcodes and make some adjustments. But the bulk of the work, especially around the state access in the database, is quite reusable. So we realize that, especially in the multi-chain feature, there could be even newer generation VMs, for example, ZK or whatnot. So we don't want to constrain ourselves to just one. So we designed our modules to be very modular and with the VM agnostic design in mind. So we make sure that we're not putting in any implementation that only works for the EVM semantics. And how we make it work is by adding an interpreter module that will sort of transfile as an interpreter layer. If we're implementing Rust, but you're doing Solidity, if you're doing Rust, or I don't know, Go or C Sharp, we'll have a way to compile that to be compatible with the core infrastructure that we're building.
Right. And so essentially, you code in a language that gets compiled into something and then it gets translated at machine level codes where it is all the same. Is that understanding correct?
So I guess the high level is that the developers don't have to do anything differently. If you're an EVM developer, you write in Solidity, you write your smart contracts, you build on certain chain, that's totally okay. And once we do the uplift to include the SVM opcodes, and now we're SVM compatible, that anyone that's already building on top of Solana or SVM stacks, that's also directly compatible. And we are not requiring any additional developer work, so to make sure the DevX is as smooth as they were before.
Okay, fair. And what is the role of hardware here with Altius? Like how important is, do we have to keep upgrading hardware as new things come along? How does that work?
That's also a great question. So what we're building and focusing a lot of effort on the state access optimization is to make sure that we are essentially building a parallel read and write and a sharded state so that instead of say running everything, putting everything in memory, which requires a really big machine with terabytes of SSD and memory, you can break that down into multiple shards, and that could be run on multiple machines at the same time. And each could have, normal 36 gig or 64 gigs. The commodity or off the shelf type of hardware you can find at AWS, or I guess even, your very high-end laptop. So we don't want to bring on performance improvements by requiring specialized hardware, because obviously the more performing your hardware is, you will have a more performant results, but not everybody could afford to run a very expensive hardware, or I don't even know where to get access to some special builds hardware this right now. So we want to bring performance without sacrificing access and decentralization to extent as needed. And a really big part of this, which I don't think has been talked about enough, is state bloat. Even if you have the world's biggest SSD and machine, if your chain is active and it's processing so much per second, you will eventually run out of state, literally run out of state. So what do? With our solution, you can just add more machines to it and to scale. So it is really about scalability, not just performance, but how can you scale into the future as you process more.
So you're saying that at some point you will have to resort to sharding this data, right? Despite like whatever you do.
So we've already implemented that. So
No. I'm saying that if someone is not doing it, they will eventually have to do it.
Or I mean, I think different teams are working on different types of solutions. Maybe it's kind of rebuilding database, or yeah, trying to find more machines, or having different tiers. You can have few expensive machines doing very specific roles, and you can have light clients, whatnot. But for us, I think hardware cost is one, but scalability, future proofing that is also very important.
Fair.